calculate e to x. E to x, it's here. E to x is the same. It's the same like E2 equal E to cosine 0 equal K. Q2 equal to Q equal to Q divided by the distance square equal A square. Excellent. We have all the values. Now we have to substitute all this value in the general equation here. E1 equal, okay, we can put the I values together and the J values together. Here we have the I values. We can take E3x before equal K 3Q divided by A radical 2 square times radical 2 over 2. Okay, this value I plus e to x I. E to x, it's here, plus k 2k 2q over a square. All this value in the direction of I, plus j direction. We have e4y and e3y. e4y equal k e4q over a square, plus e3y, it's here, equal k 3q over a radical 2 square radical 2 over 2 in the direction of j. So it's the value of the electric field vector. Okay, we can simplify. Exactly, we can do some simplification to write this equation in another form. How? Okay, we have to calculate the electric field. Okay, we have to precise. You want the magnitude of the electric field, you want the electric field vector, it depends. Anyway, we can calculate the magnitude. We can write here the x component square plus the y component square. This is the x component. Here we have the x component, and here we have the y component. Okay, the angle of this value, you can write the angle theta of E equal tangent minus 1 E. I am speaking about E1 equal E1 y over E1 x. This is E1 x, and this value is E1 y. Okay, you can get its value easily by calculation. It's okay, we calculated the magnitude of E, we calculated the angle, the direction of E. Now it's the time to calculate the total electric force exerted on Q. Here we have to be careful. We cannot waste your time. in the exam or when you want to solve any problem. When I ask you to calculate the field, after I ask you to calculate the electric force, you cannot do the same procedure. The components, no, you can. You have to calculate the force from the field. You calculated E1 equal E1 x I plus E1 y j, and you calculated E1, the value of E1, E1 x square plus E1 y square. So the magnitude value of the electric force at the point Q, F at the point 1, equal Q, the located, the charge Q, which is located at the point 1, times the field, the total field created at this point. So just we put Q, exactly, it's absolute value, okay? Absolute value times the total value E1 here. This is the magnitude of the electric force created at the point 1 because the existed charge Q. Now, if I ask you to calculate the direction of F, of F, of F, we can say if Q is positive, if Q positive, so E and F have same direction. If Q is negative, so E and F have opposite direction. So it's enough to write this. This is the answer. Thank you.